The search for new celestial objects has fascinated astronomers for centuries, and now, some scientists believe that something extraordinary may be lurking in the darkness behind Neptune. The idea of a mysterious, massive planet, often referred to as Planet 9, has captivated the scientific community and sparked numerous investigations. If proven true, the existence of Planet 9 could revolutionize our understanding of the solar system. Estimated to be roughly 10 times the size of Earth, this potential planet is thought to be a scientific marvel, one that may have evaded detection due to its extreme distance from the Sun. But why have we overlooked it for so long, and what evidence exists to suggest that such a massive object might be hiding in the far reaches of our solar system? Planet 9 is a provisional name for what is believed to be a massive object beyond the orbit of Neptune. While it has yet to be observed directly, various indicators suggest its existence. These clues are primarily found in the unusual orbits of a group of trans-Neptunian objects, TNOs, which exhibit significant orbital anomalies that imply the presence of a massive, unseen force influencing their movement. Since 2016, scientists have studied 6 such objects, including Sedna and Elianto, which are now relatively well understood, though 4 others remain elusive in terms of precise observation. TNOs, sometimes called SIDS, scattered disk objects, have clustered orbits, a pattern that hints at gravitational interaction with a very large object. The anomalies in these orbits are so pronounced that scientists are now nearly certain that something large is out there in the darkness of the Kuiper belt. But where exactly is this object, and why has it remained hidden for so long? The search for new planets in our solar system is not without precedent. In fact, 3 of the large planets, Uranus, Neptune, and even Pluto, were discovered not by direct observation but by analyzing orbital anomalies in other celestial bodies. When deviations in the orbits of known planets couldn't be explained, astronomers began to hypothesize the existence of other, more distant planets. In the case of Planet 9, scientists have been following a similar method. The pioneer of the search for Planet 9 is U.S. astronomer Michael E. Brown, who has been investigating the Kuiper belt for years. Back in 2006, he discovered Eris, a dwarf planet so similar to Pluto that it led to Pluto's demotion from full planet status. In 2012, another researcher named Rodney Gomez hypothesized the existence of a planet within the Kuiper belt, suggesting that it could be about the size of Mars, or even as large as Neptune. Brown and other astronomers, including Chad Trujillo and Scott S. Shepard, took up the challenge, and by analyzing the orbits of objects such as 2012 VP-113, they concluded that the hypothetical Planet 9 must be much larger than previously thought. By 2014, Brown and his colleagues had postulated that this planet, if it exists, would be significantly larger than Earth, and might take between 7,000 and 10,000 years to complete a single orbit around the Sun. French researchers further bolstered this hypothesis by analyzing data from NASA's Cassini space probe, which explored the region around Saturn until its mission ended in 2017. According to these scientists, the data strongly suggests the presence of a massive, yet-to-be-observed planet. After several years of relative quiet on the Planet 9 front, Brown and his colleague Konstantin Batygin renewed their research and presented new evidence in 2024. The duo's updated simulations once again highlighted the peculiar orbits of the TNOs and demonstrated that these anomalies could be explained by the gravitational pull of a planet approximately 10 times more massive than Earth. According to their calculations, the odds of the observed orbital patterns being a coincidence are exceedingly low, just 0.007%. This has reignited interest in the possibility of discovering a new planet, one that is thought to be similar in size and structure to Neptune. If Planet 9 is indeed out there, it could be one of the largest planets in our solar system, which raises an important question: how could such a massive object have evaded detection for so long? The answer lies in its distance from the Sun. Planet 9 likely follows a highly elliptical orbit, only coming relatively close to the Sun once every 6,000 to 7,000 years. For the vast majority of its orbit, it remains far out in the darkness, where it is incredibly difficult to observe. For much of the 20th century, astronomers believed that there wasn't much beyond Neptune, but this assumption has since been proven false. The Kuiper Belt is a vast region, stretching approximately 590 million kilometers from the Sun, and our exploration of it is still in its early stages. This region is home to countless icy bodies and other objects, many of which we have only begun to study in detail. If Planet 9 is out there, it is hiding in this enormous, largely uncharted area. While some researchers, like Michael Brown, are almost certain that Planet 9 exists, others remain skeptical. Some astronomers have proposed alternative explanations for the anomalies in the TNOs orbits, such as the combined gravitational influence of numerous smaller objects within the Kuiper Belt itself. There is even a wild theory that suggests a tiny black hole might be responsible for the strange orbital patterns, though this idea is generally considered to be far less likely than the existence of a planet. Despite these alternative theories, Brown and Badigeon's research continues to suggest that Planet 9 is out there, and they have calculated that the odds of its existence are over 90%. Even so, it is important to remember that scientists have been wrong before when searching for new planets. Historical examples include the failed searches for the hypothetical planets Vulcan and trans-Pluto, both of which were believed to exist based on observed anomalies but were later disproven. If Planet 9 is eventually found, it will be a monumental discovery that could reshape our understanding of the solar system. One fascinating aspect of this potential discovery is the possibility that it could restore Pluto's status as a planet. Michael Brown, the astronomer whose work led to Pluto's demotion, could be the one to bring it back into the planetary fold. If the existence of Planet 9 is confirmed, scientists may need to revise the definition of what constitutes a planet, and Pluto could once again be considered one. Naming the new planet would fall to the International Astronomical Union, IAU, and given its significance, it would likely be named after a Roman deity. There are several fitting possibilities, including Janus, the god of beginnings and transitions, which would be apt given the discovery's potential to open a new chapter in astronomy. Other options might include Somnus, the god of sleep, due to the planet's distant, dark location, or perhaps a goddess like Fortuna, the goddess of luck, in recognition of the fortuitous discovery. The next few years could prove critical in the search for Planet 9, thanks to the development of new, more powerful telescopes. 3 major observatories are set to come online soon, each of which could play a key role in finally locating the elusive planet. One of these is the Vera Rubin Observatory in Chile, which is scheduled to begin operations within the next 2 years. The Rubin Observatory will repeatedly image the entire sky over a decade, making it an ideal tool for detecting faint, distant objects like Planet 9. Its large field of view and high sensitivity will enable astronomers to track even the smallest movements of objects in the outer solar system. Another exciting development is the upcoming launch of NASA's Nancy Grace Roman Space Telescope. This telescope will be equipped with state-of-the-art instruments, including a large field of view and high-resolution cameras, making it well-suited to searching for Planet 9 by detecting its movement and any reflections of sunlight on its surface. Finally, the Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile is also being upgraded. With 66 high-precision antennas, ALMA is designed to study objects in the millimeter and submillimeter range of the electromagnetic spectrum. These wavelengths are ideal for identifying cold objects in the outer solar system, and ALMA could provide crucial data on Planet 9 once its location is known. Even though the existence of Planet 9 has yet to be confirmed, some scientists are already contemplating the idea of sending a probe to investigate. If Planet 9 follows the orbit that Brown and Badigeon have suggested, it only approaches the Sun every 7,000 years, meaning that we may be living in the ideal time to study it. However, a mission to Planet 9 would be challenging, as any probe would need to travel immense distances and take years, if not decades, to reach its destination. In the coming years, with powerful new telescopes and ongoing research, we may finally uncover the mysterious Planet 9, reshaping our understanding of the solar system. Whether it's a massive planet or something even more unexpected, the hunt for this elusive object continues to captivate astronomers and fuel our curiosity about what lies beyond Neptune. Stay tuned, space exploration is just getting started.